AWS Elastic Beanstalk is a platform as a service solution designed to help you deploy your applications without manually configuring the underlying infrastructure to host and support that application. All you need to do is upload your application source code and provide details of how you want the infrastructure that supports the application to be configured. Elastic Beanstalk will then build, deploy, and manage that infrastructure on your behalf. In this video, you will gain hands-on experience deploying a multi-tier AWS application using the Elastic Beanstalk service. You will learn about the core features of Elastic Beanstalk, its key components, recommended best practices, and security measures when deploying real-world applications in the cloud. Hello and welcome to my channel. My name is Rajesh and I am a senior solutions architect with over 20 years of experience in the IT industry. I've helped numerous clients migrate to the AWS cloud and I've worked with businesses across the US, UK, and India. Over the last 5 years, I've delivered technical training programs on AWS. I'm also the author of the AWS Certified Cloud Practitioner Exam Guide, published by Pact Publishing and available on Amazon and major bookstores. Now, I've designed this video to help you gain practical experience with the AWS Elastic Beanstalk service. If you already have some knowledge of Elastic Beanstalk, feel free to skip ahead to the hands-on labs using the timestamps below. If you are new to Elastic Beanstalk, then I highly recommend that you go through the entire video. Okay, that's enough about me. Let's start the AWS tutorial. Even though cloud computing has made it much easier to build and deploy your applications, you must still consider the vast array of infrastructure services that need to be configured to support and host those applications. And so you need to design, plan, and provision the necessary infrastructure to host and support the application. And that also means that you should configure your infrastructure components to ensure security, reliability, scalability, and high availability to ensure that your application is always available for your end users. And so in a typical infrastructure configuration, you're going to host a vast array of different components. So there will be networking components as an example. You'll need to build a VPC within which you will deploy your application. You may need to configure some load balancers to distribute traffic across your compute services within that VPC. Not to mention that you might also need to deploy CloudFront if you're hosting your application in one region but want to provide access across the globe. There's compute services that you need to configure. You need to firstly decide whether you're going to use EC2, ECS, or Lambda functions, but ultimately you still need to configure those individual hardware components. You may also need to configure some storage services, such as object storage like Amazon S3 or block storage devices that need to be attached to your EC2 instances. Let's not forget about databases. Most applications need to store structured data somewhere, and databases are sitting in the backend of every application out there, hosting valuable data. And then there's the security aspect of it. You may need to configure some IAM roles to allow your applications to interact with various AWS services on the platform. Or you may need to think about configuring encryption services so that your data is safe and secure. Let's not forget about Secrets Manager, which allows you to host database credentials and secrets, which can be dynamically retrieved by your application. And then finally, you may also need to have some monitoring and logging services. So using Amazon CloudWatch, for instance, is going to be a vital component in your overall infrastructure design. And so hopefully you're beginning to realize that hosting an application is not all that easy. And so you have to carefully plan and design not just the application, but also the underlying infrastructure that's hosting that application. Now, AWS has another solution that can allow you as a developer to focus more on your code rather than the underlying infrastructure. And that's where I'd like to introduce you to the AWS Elastic Beanstalk service. So the AWS Elastic Beanstalk service is a platform as a service solution, a PaaS solution that can help you deploy and manage your applications on AWS without having to individually configure and manage the underlying infrastructure that supports your application. As a developer, you can upload your code to Elastic Beanstalk, and Elastic Beanstalk will configure the infrastructure and the environment. The service will also provision supported platform versions to support your applications that are designed and built in supported languages such as Go, Java, .NET, Node.js, PHP, Python, and a few others. However, you do need to be aware of the fact that as a developer, you still need to understand the infrastructure and architecture design principles for your application requirements. And what this means is that you still need to be in a position to dictate exactly what the infrastructure needs to look like, how the network needs to be built, what sort of storage services you need to consume, whether you're going to go with load balancing and auto scaling, all of those components that fulfill your application infrastructure needs is something that you do need to have a good understanding of. And the reason for that is Elastic Beanstalk gives you full flexibility on how the underlying infrastructure is built and configured to support your application. Elastic Beanstalk will still do the heavy lifting of actually configuring and setting up that infrastructure, but you need to tell it what to do. You could leave Elastic Beanstalk to provision a base standard infrastructure for your application, but most of the time you're going to find yourself in a position where you need to actually be involved in how that infrastructure is going to be set up. Now, Elastic Beanstalk uses CloudFormation to build the infrastructure for your application. So CloudFormation is an infrastructure as a code solution that provisions infrastructure from code based on the templates that define how that infrastructure should be built. And Elastic Beanstalk actually makes use of CloudFormation to build the infrastructure that you are trying to set up to host your application. This is something to be aware of, and specifically the differences between Elastic Beanstalk and CloudFormation for your exam. So whereas CloudFormation will help you build underlying core infrastructure components to support one or more applications, Elastic Beanstalk is highly focused on that individual application that you're trying to deploy on AWS and provisions the necessary infrastructure using CloudFormation to support that application. So next, let's look at which platforms Elastic Beanstalk actually supports. So Elastic Beanstalk provisions your core infrastructure and environments for the following supported platforms and languages. And as long as your application is built in these supported languages and platforms, then you're pretty much good to go and will be able to deploy your application using Elastic Beanstalk. And these include Apache Tomcat for Java applications, Apache HTTPS for PHP and Python, Nginx and Apache HTTP Server for Node.js, .NET Core for Linux and .NET for Windows, Go, Ruby, and a few others. Now, a really cool feature of Elastic Beanstalk is that if your application architecture isn't built using one of these supported platforms or runtime environments, you can always use Docker containers. With Docker containers, you can define your own runtime environment, platform, programming language, and any application dependencies. Because Docker containers are self-contained and include all the software that your web application needs, you have extensive flexibility on the type of applications you can host using Elastic Beanstalk. Now, we've got two options when it comes to Docker. So the first option is to use Docker runtime on 64-bit Amazon Linux 2. This is ideal for single Docker containers, where it refers to deploying a single or multiple containers on EC2 instances. The Docker image can be built by supplying a Docker file, and Elastic Beanstalk will actually go and set up your Docker image, or you could provide it with access to a Docker image. The second option is to use ECS running on 64-bit Amazon Linux 2. ECS stands for Elastic Container Services, and it is a container orchestration and management solution offered by AWS. With this second option, Elastic Beanstalk performs all of the ECS activities, such as creating your ECS clusters, task definitions, task execution. You can also define the environmental variables in the Elastic Beanstalk console, which are then passed on to the containers. Now, an important point to note, however, about this ECS option is that your Docker images must be pre-built and stored in a repository. Unlike the previous option, you cannot simply supply a Docker file and expect Elastic Beanstalk to then build out your Docker image. Now, before the introduction of ECS as being used to host multi-Docker containers, there was an option, otherwise known as Docker Legacy, to host multi-container Docker containers, and these can actually be migrated to ECS running on 64-bit Amazon Linux 2. So if you are running an older multi-container Docker running on 64-bit Amazon Linux platform branch, those can now be migrated to ECS running on 64-bit Amazon Linux 2 platform branch. Okay, next I'd like to take a look at a typical architecture design pattern about how the various components of Elastic Beanstalk work with each other. So let's do that next. Okay, so let's take a look at the different Elastic Beanstalk components next. So here we have our developer, Menyo. He's been working for our company and he's built an application that he wants to deploy on AWS, but he doesn't want to do the heavy lifting when it comes to the underlying infrastructure. So he's going to go with Elastic Beanstalk, which is our platform as a service solution. Now, Menyo needs to actually create what's called an Elastic Beanstalk application. Now, this is not an application in a traditional sense. From an Elastic Beanstalk perspective, this application describes the container that will contain the actual application code, environments, runtime libraries, and the infrastructure components to support the application. So think of the Elastic Beanstalk application as simply a container to hold all of this stuff together. And so for the exam, remember that Elastic Beanstalk application is simply a collection of the infrastructure resources, environments, application versions, and configurations. Once you've got the application created, you can then describe and configure the Elastic Beanstalk environments. Now, what do we mean by that? Essentially, what Menyo needs to do is he needs to upload the application code to Elastic Beanstalk, and Elastic Beanstalk will deposit that code into a managed S3 bucket. So Menyo essentially uploads the application code to Elastic Beanstalk, and Elastic Beanstalk puts that application code into a managed S3 bucket. These are called application versions, and they are specified versions of deployable code that are stored as a bundle in the Amazon S3 platform. And it could be in a zip format or a WAR file stored in the S3 environment. Now, this S3 bucket is linked to your Elastic Beanstalk application. Okay, so when you create your Elastic Beanstalk application and you upload your code, an Elastic Beanstalk bucket is created if one doesn't already exist to support and host the application code. Next, for the application, Menyo will need to create one or more environment. So when you're deploying applications on AWS, usually you're going to deploy it in multiple environments. There'll be a dev environment, a test environment, and a production environment. And usually you'll have different application versions deployed across those environments, where the production environment will usually have an older, more stable version of your application code, as opposed to your dev environment where you may be testing out some new features, for example. As part of your Elastic Beanstalk configuration, Menyo does need to be aware of the core infrastructure components that is going to support that application. Now, Menyo is not going to manually configure most of that infrastructure. Elastic Beanstalk will do that heavy lifting. Nevertheless, Menyo needs to describe whether we're going to be using a default VPC or a custom VPC, whether we're going to be using auto-scaling services, how many instances, what sort of auto-scaling policies we're going to have, whether we need an elastic load balancer to distribute traffic across those instances, and also if we need a backend database. In addition to that, Menyo will also need to specify any service rules and instance profile for your EC2 instances. And IAM roles are basically assumed by Elastic Beanstalk as a service role and EC2 instance profile to allow Elastic Beanstalk to create and manage your environment. So this becomes an absolute necessity when you think about permissions and the ability for your instances to interact with other components of the AWS service. Once this environment is configured and set up, Elastic Beanstalk will then go ahead and actually deploy your application versions to your environments and provision your application within those EC2 instances ready for your users to be able to interact with them. Some other components that might be included as part of that configuration that Menyo needs to be aware of is things like whether you want to export log files to CloudWatch, the health monitoring of your services, if you want to send out email notifications to the administrator whenever events takes place in your Elastic Beanstalk environment. And so ultimately, Menyo does need to be aware of the core infrastructure components that is going to be used to support the application, but Elastic Beanstalk actually goes and provisions all of these infrastructure bits and pieces using CloudFormation. Okay, so this describes at a very high level what an Elastic Beanstalk environment looks like and what its various components are. However, there's a little bit more to it when it comes to the environments that Elastic Beanstalk allows you to create. Let's take a look at that next. When considering using Elastic Beanstalk to host your application on AWS, you do need to take into account the complexity and the architecture design patterns of your application. If your application is designed with a front-end element and a back-end element to it, as most production enterprise-grade applications are, then you want Elastic Beanstalk to take this into consideration when building out the necessary environments to support and host that application. Now, front-end refers to the presentation layer of your application. Using a combination of technologies like HTML, JavaScript, and CSS, developers build the user experience element on the web page, such as buttons, menus, pages, links, graphics, and so on. Backend refers to the server-side development and focuses on the backend operations of your application. An example could include when you visit an e-commerce website where you purchased an item and are now trying to pull tracking information on your order. Backend services will retrieve the status of your order and present that data to the front end. Often, backend operations may take longer and need to keep up with incoming requests made on the front end of the application, and in this scenario, it is recommended to separate front-end requests from backend processes and use a queuing system to host and manage pending requests. To support both front and backend components of your application, Elastic Beanstalk offers what's called environmental tiers. These are called web and worker tiers. Let us look at how this all works from an architecture perspective. If you have a really complex application that has both a front end and a back end element to it, Elastic Beanstalk can provision what are called environmental tiers to support your application architecture. And so when it comes to deploying your application, you do need to specify whether you're deploying it for the front end or the back end processing element of your application. You start off with the Elastic Beanstalk application, which is the ultimate container that will host the application, the infrastructure, and the environment for the application. In addition to that, Elastic Beanstalk will provision and manage an S3 bucket, which will be used to host all of your application versions. When it comes to deploying the application within Elastic Beanstalk, you need to specify if you're deploying it for the front end part of your application or for the back end part of your application. Accordingly, Elastic Beanstalk will provision a web tier, that's for the front end, or a worker tier, which is for the back end. When it comes to actually provisioning the resources for those environmental tiers, Elastic Beanstalk will provision one or more EC2 instances depending on the configuration that you choose, and will deploy the application on those EC2 instances. The instances for the web tier will be supported by an auto-scaling group and scaling policies to help you scale out or scale back in depending on the sort of load that you have on your instances. You can actually define what that scaling policy is as well. In addition to that, for the web tier, Elastic Beanstalk provisions an application load balancer so that it can distribute traffic coming from the internet to those EC2 instances. Now, Elastic Beanstalk will provision the EC2 instances for your application, which will be dependent on what's known as the container type. The container type basically defines the infrastructure topology and the software stack that will be used by the environment. You need to tell Elastic Beanstalk what platform your application has been built on, what language is being used, etc. And Elastic Beanstalk will then provision the appropriate container type. So for example, an Apache Tomcat container would comprise of an Amazon Linux operating system, Apache web server, and Apache Tomcat software. Likewise, for your worker environment, again, Elastic Beanstalk will provision one or more EC2 instances. These instances will be supported by an auto-scaling group and auto-scaling policies. Note that there is no application load balancer being configured for your work environment. That's only for your web environment. An additional component that's configured within a multi-tier environment, such as the one that you're looking at on the screen, is the fact that Elastic Beanstalk provisions an SQS queue. Now, an SQS queue is designed to take messages from the web tier and hold it in the queue. And these are going to be basically the requests made from your users coming in from the front end. Within the backend instances, there is something called an SQS daemon that runs as an agent on those instances, waiting to retrieve any messages that have been placed in the queue. And these are then retrieved and processed for backend operations. The daemon pulls the items from the queue, processes the messages, and if successful, deletes the messages from the queue. And as new messages come into the queue, this process continues. By utilizing a queuing system, we can ensure that backend instances that need to do a lot more processing aren't overloaded with massive amounts of incoming requests that hit the front end. And this helps to manage your front end and backend operations very seamlessly. When it comes to managing the scaling for the backend instances, AWS uses a number of different metrics in order to manage the scale out and the scale in of those instances. One such metric is the approximate number of messages visible CloudWatch metric that is used to define whether Elastic Beanstalk should scale out and provision more EC2 instances or cut back and terminate certain EC2 instances. And once all of this is set up, obviously your customers are able to come into your application load balancer and access your web services. Their requests are processed and sent to the queue and then retrieved by backend instances to perform all necessary backend operations. An additional point that I want to highlight with regards to this entire infrastructure setup by Elastic Beanstalk is that Elastic Beanstalk provisions each instance with something called a host manager. The host manager is an agent that runs on all of your instances that manages the deployment of applications, generating instance level events, monitoring the application server, patching instance components, and publishing application log files to S3, amongst a few others. Okay, now that we've looked at environmental tiers in a little bit more detail, it's time to move on to look at an actual application design. But before we do that, there's one more element of your typical application architecture that I want to discuss with you. And that is the placement of relational databases for your application stack. Let's do that next. Now, within a standard Elastic Beanstalk deployment, Elastic Beanstalk will provision for you the application. Okay, so that's the container, the S3 bucket to host your application code, your bundles, and the versions of application code. When configuring your environment, you can actually specify an existing VPC to deploy your application into, or on the fly, set up a brand new VPC. You can also define the environment, and then within that environment, choose your instances that you want to deploy within the autoscaling group configuration. You can choose the autoscaling policies as well. And like we've previously discussed, also deploy your application load balancer and define your application load balancer properties there. One of the fundamental elements for most applications is that they need to store data in some form of database. And as part of your Elastic Beanstalk configuration, you can actually configure a database on the fly, so a relational database, as part of your overall configuration. When you configure your application this way, you are essentially integrating the RDS database within the environment. And this comes with a lot of benefits. So for example, Elastic Beanstalk is seamlessly integrated with RDS. And that also means that the settings for your environmental properties, the settings to connect to your database, are automatically set. So the environmental properties comprising of the database hostname, the port number, the username, the password, and the database name are all set for you and ready to go. And then you just need to test your application and make sure that it connects to the database. But with this integration in place, it's very seamless. Your application and your database are all part of that environment. Now, with some advantages, also comes some disadvantages. So let's take a look at that next. If you choose the option to integrate your RDS database deployment with your Elastic Beanstalk environment, then there's a few things that you need to be aware of. Firstly, this configuration means that the Elastic Beanstalk environment will provision and manage that database for you. If you ever need to deploy another version of this application, perhaps in another environment for testing purposes, then what that means is the Elastic Beanstalk service will deploy another database in that new environment. And so now you have two separate databases supporting two environments in your application. It is likely that you are simply trying to make modifications to the application code rather than the actual data being held in the database. And so if anything, both of those environments need access to that same data. However, in this configuration, we now have a brand new database that perhaps doesn't have the same data as the previous environment's database. And so you may have some management overhead where you may need to copy some of that data from the old database to the new database. Another important point to consider is that when you are using your standard default configuration for setting up an environment that has the database integrated within it, the default database deletion policy is to delete the database when you terminate the Elastic Beanstalk environment. Now that means if you go ahead and delete that environment, then you're going to lose data as well. And this is something that you need to be aware of. So when it comes to terminating the environment, obviously Elastic Beanstalk will terminate the core infrastructure, it will terminate all of the instances, but it will also terminate the database, resulting in data loss. If you were mindful of how the database deletion policy needs to be set because you wanted to retain that data prior to getting rid of the environment, then obviously you would have made that modification then. But this is something to be aware of, that the default policy is set to delete of the RDS database when you go to delete the environment. Now, in cases where you already have a database integrated as part of your environment, you may be wondering whether it's possible to actually remove that database from the environment and separate it out from the environment. And the answer is yes. You can do something called decoupling of your database. So you can modify the database settings in your environment so that you can decouple the database from the environment. And decoupling a database will not affect the health of the environment. But the thing to be aware of is that the database will follow the deletion policy that you choose, and that is something you really want to be aware of. So what happens if you've already set up an environment and perhaps you've used a standard deletion policy, the default deletion policy, and now you've made a decision that you want to decouple that database from the environment because you want it to support other environments? Let's take a look at that next. So next, I'd like to walk you through the steps to decouple your database. And one such reason why you might want to do that is because you've decided to introduce additional environments into your Elastic Beanstalk deployment, and you want to share that database across those environments. You may also want to get rid of some other environments that you no longer use. And so now you've come to the decision that you need to decouple that database. So the steps required to decouple the database are as follows. The first thing you want to do, and this is just a precautionary thing, is to create an RDS DB snapshot. And so ultimately from within the environment, you can edit the environment and do a snapshot of that database so that Amazon RDS stores a snapshot for you in case something goes really horribly wrong. The next step is you want to enable delete protection in the RDS console of that database. Now, this is something, again, that's just a precautionary measure, primarily because when you set up the environment originally, if you didn't pay attention to the configuration items, you may have left the deletion policy set to delete. So what we need to do is we need to enable delete protection against the database itself, and you do this from the RDS console. Next, you create your brand new environment. Okay, so if you're doing this because you're shifting environments, you've got a new application code that you've deployed and you want to share that database, so you go ahead and create your brand new environment with your instances, you deploy your code, your load balancers, etc. However, in this environment, you do not provision a database as part of the environmental configuration steps that you take to deploy the environment. When you have deployed your new environment, the green environment in this case, what you want to do is you want to make sure that your application is connecting to the database. So you may need to just test that out and ensure that all of that is working. Next, you want to perform something called a blue-green deployment or a URL swap. Another word for it is a CNAME swap. So when you have deployed your application on Elastic Beanstalk provides you with a URL to connect to your application, and your users generally would connect into the application through a hosted zone that Elastic Beanstalk manages for you, and it publishes that URL that is then accessible from the internet. So your users are able to come in and access your application. Elastic Beanstalk offers you a service called a CNAME URL swap. Because you're able to create multiple environments, you can perform something called a URL swap, so that now that you have the new environment, what we call the green environment, you're able to just perform something called a CNAME swap that will send traffic to this new environment. It's a very simple process. You do it in the console or using the command line and the job is done. It takes a matter of a few minutes. You do need to bear in mind that obviously with DNS, you need to give it some time to propagate across the internet. Okay, so once you've performed the blue-green deployment and done the CNAME URL swap, give it a bit of time and ensure that your users are now able to connect to the green environment, hence the name blue-green deployment. Once you are satisfied that everyone is now connecting to the green environment, the next step is to update the deletion policy in the environment of Dev1, so the blue environment, so that you select the retain option rather than the delete option that is the default option when you are building out this environment. And this is important. You want to make sure that you do this setting first, save the setting so that it gets registered with Elastic Beanstalk before you take the next step. And then the next step is to perform the actual decoupling exercise from the screenshot that I'd shown you earlier in this video. You perform the decoupling exercise that will decouple the database from the environment. And at that point, you want to make sure that your new environment can still connect to the database, run all your tests, and then finally you want to terminate the old environment. And so these are the steps that you would take when, if you have started off with an environment that has the database tightly coupled and the deletion policy was set to delete, so all of the default configurations, and you've decided that you want to decouple the database and build new environments. So you want to follow these steps very carefully. Now, if you're taking the AWS Solutions Architect exam, you probably want to remember these steps as well, because you might get a scenario type question there. Okay, so you obviously now have the steps to follow if you find yourself in a situation where you've built an environment with your database tightly coupled and then you want to decouple it later on. However, in the real world, when you build, design, and deploy your applications on Elastic Beanstalk, it pays well to plan your environment build out beforehand. It is possible to connect your environment to an external RDS database that's managed outside of those environments separately. And often this can be a good step to take because it takes away all of this heavy lifting that you might have to do later on. So next, we're going to be taking a look at how to build a typical architecture design pattern to support any future Elastic Beanstalk deployments within a real life scenario. We'll then move on into a lab environment where I'll provide you with some sample application code, a fully functioning application code that you can actually use to build out a real world type environment in your own AWS account. Okay, so let's do that next. Okay, so we've covered a lot of theory, and obviously now you're itching to try and really work with the Elastic Beanstalk service. So that's exactly what we're going to do next. I want to walk you through an architecture design diagram. Now, this is by no means a complete end-to-end solution. It's a cut down version of what you will deploy in the real world, but it will help you understand the core components that actually go on to build a real life project. There are several components to help you deploy, host, and manage your application on the AWS platform. And we're going to be looking at some of these services next. Elastic Beanstalk is a platform as a service solution that can help incorporate all of these different services to provide the necessary infrastructure for your application. So let's get started with the architecture design plan. Unless you're going pure serverless, you're going to need a VPC. Your VPC is the isolated network within which Elastic Beanstalk will deploy your application. You can set up VPC up prior to actually working with Elastic Beanstalk, or whilst configuring Elastic Beanstalk, set one up on the fly. We'll be setting one up in the lab from scratch, and I'll show you how to set this up. Now, our VPC is going to follow some best practices. So we are going to be using our VPC across 2 availability zones. Remember, VPCs span the entire region. For the purposes of this lab, we're going to make use of 2 availability zones for high availability purposes. We're then going to be deploying 6 subnets. 2 subnets are going to be reserved for public subnet services. Okay, that's where we're going to be hosting our load balancers and our NAT gateways, and I'll come on to that in a second. But we're going to be having 2 public subnets, one in each availability zone to offer that redundancy, that high availability element. We're going to have 2 private subnets that are going to be used to host the application itself. Again, one in availability zone US East 1A and the other one in US East 1B. And then we're going to have another 2 private subnets that's going to be used for our database. We're going to be using a MySQL database for this project. So we're going to work with the RDS service and deploy a MySQL database in our VPC. Obviously, with a VPC, we're going to deploy an internet gateway because the VPC will need internet access. And in addition to that, we're also going to be deploying a NAT gateway. A NAT gateway allows instances in the private subnet to get access to the internet by way of a proxy, by way of a relay service that the NAT gateway service provides. Okay, and the reason why we are doing this is because our instances may need to access the internet, they may need to download software, updates, and all that stuff. So a NAT gateway is also going to be deployed. Now, bearing in mind, all of this configuration is going to happen well before we actually work with Elastic Beanstalk. And the primary reason for that is because we want to host our RDS database outside of the Elastic Beanstalk configuration and environment. And as a result of that, we have to set up the necessary infrastructure to host that database first. And so we're setting up the VPC. Another element of the VPC that we need to configure are security groups. Security groups allow you to ensure that you only allow the type of traffic you want to allow inbound to the resources that are available in your VPC. So in the case of the database, we obviously want to allow inbound traffic to the database on port 3306, which is the port number for MySQL by default, and we need to set that up. And so we will be configuring a security group for our database, and it will need to be configured traffic on inbound port 3306. Now, obviously, when you set up the security group for the database, you need to define the source of that traffic. So we will be setting up an additional security group, one that we will attach to our instances that Elastic Beanstalk deploys. Now, bear in mind that Elastic Beanstalk will also deploy a security group for those very same instances so that it can allow the instances to be able to accept traffic inbound from the load balancer that it configures later on. So your instances will actually have 2 security groups attached to them. One will be the one that we're configuring now, which is the app SG security group, and another one which will be configured by Elastic Beanstalk. Now, the reason for doing this is because I want to restrict inbound traffic to our databases on port 3306, but only from instances that are associated with this app SG security group, ensuring that it's only the instances that Elastic Beanstalk deploys that will be able to talk to my database. Okay, so that's an additional security measure we're trying to preempt and configure. Okay, so we will be creating these two security groups manually as well. The next thing that we will be doing obviously is deploying our database. So we will be going into the RDS management console. We will deploy a MySQL database. Now I've put in a second database here in US East 1B, but I've grayed it out because when we come to do the lab, we'll just be deploying the single instance. In a real world scenario, you want to be deploying a multi-AZ configuration for the purposes of high availability. But as this is just a lab environment and I'm trying to keep the cost down, and if you were to do this in your own AWS accounts, I want you to keep the cost down. And so as a result of that, we'll just deploy the single DB instance. Okay, so far we've got our base configuration set up in place. Now, as a next step, we're also going to be using AWS Secrets Manager. Now, AWS Secrets Manager is a service that allows you to host database credential secrets so that you can dynamically retrieve them into your application, and your applications can make connections to the database. Remember, your databases will have some credentials in order to authenticate against it. That information will be stored in Secrets Manager. The application code that I'm supplying you for the purposes of this lab, which is available to you in our GitHub repository, is configured and designed in such a way so that it can actually work with Secrets Manager. And so what we'll need to do as a precursor is configure Secrets Manager. So we'll go into the Secrets Manager console, we'll set up the secrets for our database. Another feature of AWS Secrets Manager is the fact that you can enable something called DB rotation, database rotation. Now what this does is it actually changes and rotates the database credential information at regular intervals. You can set those intervals yourself. It can be every 4 days, 4 weeks, 4 months, whatever is your corporate policy. But this is an absolutely important security feature because what it means is that you can have the database credentials automatically rotated by Secrets Manager. Secrets Manager updates the secrets in its database as well with what the new credentials are, and that information is then available to your application to be able to access the database. This further enhances the security of your overall application in the AWS platform. Another key component that we're going to be working with is IAM, and we're going to be configuring an IAM role for the purposes of creating an EC2 instance profile, which will allow your EC2 instances to interact with services such as Secrets Manager, as well as work with Elastic Beanstalk services. Okay, so we will need to configure an IAM role with the appropriate permissions, and I'll show this in the lab. So far, we've built out all of this infrastructure outside of the Elastic Beanstalk configuration. And remember, the reason why we're doing this is because we want to set up our database externally to the Elastic Beanstalk environment. Next, we're going to actually work with Elastic Beanstalk. So here's our developer Menu. Menu has got the application code that he wants to deploy using Elastic Beanstalk. He's going to configure the Elastic Beanstalk application as we've seen previously, upload the code to Elastic Beanstalk, which will involve Elastic Beanstalk setting up an S3 bucket to manage that application version and bundle. And as part of the Elastic Beanstalk configuration, Menu will instruct Elastic Beanstalk to perform the following configurations. So one of those will be configuring an application load balancer. Menu will instruct Elastic Beanstalk to design the application environment for high availability, and therefore this will entail configuring an application load balancer. So Elastic Beanstalk will then configure that application load balancer when it deploys the application. Another component that Menu will instruct Elastic Beanstalk to take care of is the auto-scaling group and also environment properties. Now, environment properties need to be manually updated with information to access the database that is external to the Elastic Beanstalk environment, and also the name of Secrets Manager, the name of the secret within Secrets Manager to pull the secrets from. So whereas when you deploy Elastic Beanstalk environments with the database integrated within it, the environment properties is set for you. Because we're trying to keep the RDS database external to the Elastic Beanstalk environment, this is one thing that you will need to do, that Menu will need to do. He will need to set up the environmental properties to connect to the database. So you'll need to provide the database endpoint name and also the secret name within Secrets Manager that is hosting the credential data. Once Menu has set up all of the necessary configuration and submitted the request to Elastic Beanstalk, Elastic Beanstalk will go ahead and provision the necessary security groups. As I mentioned earlier, so Elastic Beanstalk will be setting up a security group for the load balancer to accept inbound traffic on port 80 from the internet, and then also setting up another security group for the instances to accept inbound traffic on port 80 from the load balancer's security group. So from the load balancer. Okay. And because the instances also are associated with app.sg security group that we created manually, the instances can now also talk to the backend database. In addition to that, Elastic Beanstalk will obviously consume the application code and deploy the EC2 instances as per the configuration of the auto-scaling policies and deploy the application on those instances. Those instances will be able to consume the data in environment properties. So that is, the name of the database, the name of the secrets that contains the credential data, and ultimately the instances will then be able to retrieve the data from Secrets Manager, the credential information, and access the backend database. At this point, Elastic Beanstalk has deployed the application successfully and delivered a DNS name for the URL of the application. And then Menio can distribute this URL to the end users to access the application. Obviously, you can go one step ahead. You can associate a custom domain name within Route 53 and associate it with this Elastic Beanstalk URL. And that's it. So enough of all of this theory. Let's jump into the AWS Management Console, set this all up. Now I've actually broken this lab exercises into multiple steps for you so that it's easy to follow. So for step 1, let's go into the AWS Management Console and create that VPC. Okay, so here we are in my AWS account, and the first thing that we're going to work with is the VPC. We're going to build out a virtual private cloud, which is going to be our isolated network that will host our application. Now, this VPC is going to comprise of 6 subnets across 2 availability zones, an internet gateway, a NAT gateway, and the 2 security groups that we spoke about earlier. So let's go ahead and create our VPC first. And I'm just going to go into the VPC Management Console, open that up in another tab. And we're going to go into your VPCs, and in there, we're going to click Create a VPC. Now we're building a VPC from scratch. I want to walk you through all of the steps rather than use the wizard so that you see exactly what's happening. We're going to give this VPC a name. I'm going to call it the dev-VPC. And the IPv4 side default block is going to be 10.0.0.0/16. Now, if you're interested in learning more about VPCs in a bit more detail and best practices for how you define your IPv4 side block ranges, then check out our course, the AWS Certified Solutions Architect and the Cloud Practitioner, on our website, iasacademy.com. Okay, so next we're going to go ahead and click Create VPC. And this creates the basic core VPC in your AWS account. Okay, so that's our VPC created. The next step is let's give this VPC an internet gateway. So we're going to go ahead and click Internet Gateways, click Create a new internet gateway. We'll give this one a name. So I'm going to call this dev-IGW, Internet Gateway for short, and click Create Internet Gateway. Now, when you create the Internet Gateway, it isn't attached to any VPCs. So you're going to have to attach it to the VPC you just created. So click Attach to a VPC. Click in the box, select your VPC that you just created, and click Attach Internet Gateway. At this point, your VPC has an internet gateway, so we can move on to the next step. So we're going to create 6 subnets. Remember, there are going to be 2 public subnets that's going to host our edge services like the load balancer and the NAT gateway, and 4 private subnets, 2 for the application layer, which will host the instances that Elastic Beanstalk will configure, and 2 for our database that we'll create using RDS. So we're going to go into subnets, and I'm going to click Create Subnet. Make sure you select the right VPC that you're placing the subnets in, and define your subnets here. Okay, so we're going to start with our first subnet. This is going to be dev-public subnet 01, and we're going to place that in availability zone 1A, and the IP block for that is going to be 10.0.1.0/24. So this block is a subset of our VPC's block. Remember, our VPC was 10.0.0.0/16, which comes with 65,000 odd IP addresses. This is just a subset of that block, 10.0.1.0/24, giving you a total of 256 addresses. But on AWS, you have 251 available usable IP addresses. Okay, click Add a new subnet. We'll give this one a name. And this is going to be our public subnet 2. I'm going to place this in availability zone 1B. and the IP block for it is 10.0.2.0/24. Okay, add a new subnet. This time we're going to do our private subnet. So I'm going to call this one the app subnet. Okay, O1. This is where we're going to host our instances. And we're going to do it in such a way so that it's aligned with our public subnet. So whereas we have public subnet O1 in availability zone 1A, our app subnet O1 is also going to be in availability zone 1A, whereas app subnet O2 is going to be in availability zone 1B. So hopefully you're beginning to see the pattern here. So this is going to go in 1A. The IP block for it, I'm going to go and put 10.0.10.0/24. You want to leave a gap between your different subnet categories. And the reason for that is if we ever need to add additional subnets, like additional public subnets or additional private subnets, we want to make sure that it's within its relevant ranges. So what we can think of this is that we're putting all of our public subnets between 10.0.1.0 and 10.0.9.0, and we're putting our private subnets 10.0.10.0 to 10.0.19, so 0. So if you ever need to add additional subnets, you can add them in there. I'm going to add another subnet. This is going to be the app subnet O2, and this is going to go in availability zone 1B. And I'm going to give the IP block 10.0.11.0/24. Okay. And then we need to set up our database subnets. So we'll create subnet 5 dev-data subnet -O1. And this is also going to go in availability zone 1A. For this subnet, I'll give it the IP address 10.0.20.0/24. Okay. And then finally, we'll have our database subnet O2 in availability zone 1B with an IP block of 10.0.21.0/24. Okay, and just check that it is all okay. So that's 1.0, public subnet 2, app subnet 1, app subnet 2, data subnet 1, data subnet 2, and create subnets. And that will create all of your subnets for you. Fantastic. Now that we've got all the subnets created, the next thing we want to do is we want to set up our route tables. So the route tables will define exactly how those subnets can send traffic to each other and outside to endpoints such as the internet gateway. So we're going to go ahead and take a look at our route tables next. So click on route tables, and when you create a VPC, it creates what's called the main route table for you. Now subnets, when you create them, they attach themselves to the main route table by default. The main route table is this one over here. So this is dev VPC. I'm just going to edit that name and just say dev main RT, just so I know what it is. And if I look at the routes and look at the subnet association, you will see that all of the subnets are associated with this route table. The routes has just one internal route. Now, when you're setting up a VPC, you want to make sure that your public subnets have their own route table with routes to the internet that are explicitly for public services. Okay, so we've got our main route table already. So we're just going to create one more route table. We're going to create the public route table that we're going to attach to our public subnets. So click create a route table, and we'll call this one dev-public RT. Select the right VPC and click create route table. And that creates a route table for us, which is called the public route table. Now, if you remember, we've got our internet gateway. So we're going to set up a route for the public route table. We're going to send traffic to the internet via this route table or using the routes defined in this route table. So we'll click edit routes. We'll click add a route, and we'll add a route to the internet. So the 4 zeros /0 represents external networks or any network outside of this range. And the target for that is going to be our internet gateway. I'm going to select our internet gateway, and we're going to save changes. At this point, this route table gives you direct access to the internet via the internet gateway. And so as an additional steps, we can go into subnet associations, click edit subnet associations, and select the public subnets and click save association. So what's happened is the public subnets, as we call them public subnets, are now truly public subnets because they're associated with a public route table that has a direct access to the internet via the internet gateway. So if I take you back into subnets association again, you will see that the two public subnets are explicitly associated with the public route table. The other 4 subnets that we have are associated with the main route table. Okay, so if we go back to route tables and click on the main route table. Now the main route table has just a single route, which is an internal route. The instances that we deploy in the app subnets are associated with the main route table. Now those instances will also need internet access, but we want to make sure that we keep them private. And so rather than exposing them with a public IP address and associating them with a public route table, we're going to create something called a NAT gateway. So I spoke about a NAT gateway a little bit earlier, which is basically a method of granting access to instances that you deploy in a private subnet by way of a proxy. Okay, so the NAT gateway acts as that proxy, as that relay machine to relay internet requests from those instances in the private subnet out to the internet, and then translate back responses to those instances when the replies come back from the internet. So the next thing we need to do is create a NAT gateway. So I'm going to go click create a NAT gateway, and we're going to give it a name. So we're going to call this dev NAT GW, and you need to place the NAT gateway in a public subnet. And the reason for that is because the NAT gateway will need a target to send those internet requests through. And in this case, it will be sending it to the internet gateway. And in order to send traffic to the internet gateway, it physically needs to sit in a public subnets, because the public subnets are associated with the public route table that has that route defined to the internet gateway. Okay, so normally what you would do is when you have multiple public subnets across multiple availability zones, you will create multiple NAT gateways for redundancy and high availability. But for the purposes of this lab, we're just creating one NAT gateway, and I'm going to put this in public subnet 1. Okay, so that's this one over here, dev public subnet 1. And this will just ensure that we keep our costs down for the purposes of the lab. But in the real world, you definitely want multiple NAT gateways across multiple public subnets across multiple availability zones. You also need to be aware of the fact that NAT gateways need to have an elastic IP address associated with them. Now, an elastic IP address is basically a public IP address that is static and doesn't change. So we're going to allocate an elastic IP address to our NAT gateway, and then go ahead and click create NAT gateway. At this point, your NAT gateway is getting created. It takes a few seconds, and then it is all good to go. But if I click on NAT gateways over here again, you will see that it's in the pending state, and it will swiftly change into being available. Okay, so after a few seconds, that changed to the available state, and you can see it's been allocated with a public IP address as well. And so this is our NAT gateway. And so to complete this process, we now need to go back into route tables and click on the main route table, click on routes, and we'll create a route to the internet. So the route to the internet is going to be indirect, not via the internet gateway, but instead via the NAT gateway. Okay, so that will help us select our NAT gateway, and we click save. And so at this point, any resources that you deploy in the public subnets have a direct access to the internet via the internet gateway, provided they've been allocated a public IP address. Any resources such as EC2 instances you deploy in the private subnets can also access the internet, but via the NAT gateway, and continue to have just a private IP address, and that way you keep it secure. And this is considered best practice. You don't want to expose any of your servers out on the public subnet unless you absolutely have to. Okay, so now at this point, we've set up our VPC, our internet gateway, our NAT gateway, 6 subnets, and configured the route tables. The last thing to do in our VPC management console is to set up those security groups. So let's do that now. So we go down to security groups, and we're going to be creating 2 security groups. We're going to create one for the database and one that will assign to any instances that Elastic Beanstalk provisions in the Elastic Beanstalk environment. So security group 1, I'll call this one dev-app SRV-SG. So basically it's the app server security group. Okay. And we'll give it the same for the description. Obviously, you can give a much better description than that. And we need to make sure we place it in the right VPC. So that's the dev VPC. Because you're creating a security group, we want to create an inbound rule. I'm just going to create in HTTP rule from any location. Okay, so we are accepting inbound traffic on port 80. So the app service will be able to accept HTTP traffic on port 80. And that's from any location, and we'll create a security group. Okay, so that is the app server security group created for you. Okay, so there it is. So I'm also going to just copy that name and edit the name tag just so that it's in there and it's easily visible, so I know which security groups I'm working with. Create another security group. This is going to be dev database-sg. So this is a database security group. Okay, and again, make sure you put it in the right VPC. Now this time the inbound rules are going to be the MySQL traffic, so MySQL Aurora, which defaults to port 3306. We will be using the default port range, and the traffic for that is going to come from any instance associated with the dev app server SG. So that basically means that unless you're a member of dev server app SG, you cannot talk to my database, which is an additional security measure. Okay, and then we'll create that security group as well. And again, just go back into security groups and just make sure that you've got that name edited in the name column, just so that it's easily visible. Okay, so that's our VPC. We've got our VPC, our internet gateway, our NAT gateway, we've got our 6 subnets, we've got our security groups, and we're pretty much good to go to the next step. Step 2, let's launch an RDS database in our VPC. Okay, so back into my AWS Management Console, we're going to move into RDS. So I'm just going to search for the RDS service here and open that up in another tab. Okay, and that will bring up our RDS console. Now, when you're setting up an RDS database, you're going to launch it in your VPC. And if you remember, we had set aside 2 subnets, okay, data subnet 1 and data subnet 2, which will be used to host our database. Now, prior to actually launching your database, you need to create something called a subnet group. A subnet group is essentially telling RDS which subnets are going to be used to launch our database. And you need a minimum of 2 subnets, ideally across 2 availability zones that you need to define for your subnet group. So that's what we're going to do first. So on the left-hand side, I'm going to click on subnet groups and then click create a DB subnet group, and we're going to give it a name. So I'll call this dev DB subnet group. Okay, and we can just use the same name for the description. Make sure you select the right VPC, so that's the dev VPC, and then the availability zones that we've defined in our VPC are for availability zones 1A and 1B in the US East 1 region. Within those 2 availability zones, we're going to be deploying our database in the database subnet 1 and database subnet 2. Now, it's a little bit difficult to see it here because it just shows it to you in the form of an IP address and the subnet IDs. But if I quickly go back to my VPC console and I click on subnets, then I know for a fact that database subnet 1 was 10.0.20.0/24 and database subnet 2 was 10.0.21.0/24. So those are the 2 subnets that I want to select. So from this drop down list, I'll select the subnet 21 and 20, those 2. Okay, so those are going to be my database subnets, and I'll click create. And that creates my DB subnet group within which I will launch my database. Fantastic. Right, now that we've got the subnet group in place, let's click on databases. Okay, and we'll create a new database. And we're going to set up a standard create database. You want to select MySQL for this exercise. We'll leave all of the defaults in terms of the edition and the engine version. And select free tier because we want to make sure that you don't get charged. That will turn off some options, unfortunately, but that's fine. We're not going to use it for the lab anyway, specifically around things like multi-AZ. Now we have to give our database instance a name. So I'll call this one devdb. Okay, and for the credentials, I'm going to leave the master username to admin. Okay, and I'm going to give it a password. And I'm choosing a very simple password, but in the real world, you want to choose a really complex one. Okay, and we're not going into managing master credentials in Secrets Manager because I want to do Secrets Manager a bit separate as a separate exercise because I want to show you how it all works. So for now, just set a master username and a password of your choice. Make sure you remember the password, otherwise you will not be able to access the database. So make a note of it somewhere safe. We'll scroll down and we'll select the default option of DB-T3 micro instance type for our database. It's going to use a general purpose SSD with an allocated storage space of 20 gigs. And I'm going to disable the enabled storage auto scaling because we don't need it for the purposes of this exercise. So I'll just deselect that. In terms of connectivity, so this is where you need to make sure that you select the right VPC. So that is the dev VPC, and leave the setting to don't connect to an EC2 compute resource because we will be getting Elastic Beanstalk to provision the instances to talk to our database. Because I've selected the right VPC, it's picked up the fact that I've got a single subnet group in there, the database subnet group, so it selected that for me already. Ensure that it's set to no under public access because this database is sitting in the back end, right, in the private subnet, so it doesn't need public access, no public IPs. And then you need to select the security group for your database. Now we've already created a database security group when we did the VPC section of this exercise. So untick default and from the drop-down list, select database SG. Okay. Availability zone, we'll select 1A is our preference where we want to place our database. Expand additional configuration, just make sure that the default port is set to 3306, which is exactly what we want. Scroll down a little bit further, we'll leave the database authentication to password authentication. And then you want to expand additional configuration. Now here you need to provide a database name. So I'll use the same name, devdb. We'll set the backups to enabled. We'll set the retention period to 1 day. Okay. And we can leave the encryption enabled as well. So with encryption, it's going to use the default KMS key for RDS. And if you're interested in learning more about encryption and KMSs, check out our website for some more videos on that. I'll leave everything else at its default settings. Okay. And I'll scroll all the way down and click create a database. Now, this takes a good 5 to 10 minutes to create. So you probably want to go ahead and grab yourself a cup of coffee, tea, or whatever. I'm going to pause the video over here, and then when it's all done, I'll resume the video. So here we are, our database has been launched and configured and is in the available state. If we actually take a quick look at the database, so you've got your connectivity and security details here. So that is your endpoint. Okay, so that is what your application needs to connect to. In addition to that, the application will need to know the database name, which is DBDB, and obviously the username and password. And these pieces of information, especially the username and password, we're going to configure in Secrets Manager. So now that we've set up the database, okay, the next step is to move on and work with Secrets Manager and configure Secrets Manager to store the credentials of this database. Let's move on to step 3 next. Okay, let's move on to step 3, where we're going to go into Secrets Manager and configure a secret for our database. Okay, here we are back in my AWS Management Console. So I'm just going to go into Secrets Manager, open that up in another tab. Okay, so in Secrets Manager, we're going to go ahead and store a secret. Now, Secrets Manager will allow you to store credential data for your RDS database. The service also provides the ability to rotate your credentials for databases like RDS, but we'll do that a little bit later. Initially, what we want to do is click Store a New Secret, and you want to select the secret type as being credentials for an RDS database. Next, you're going to put the username and the password for your database. So hopefully you made a note of it. Okay, we don't need to make any other changes other than select the database that we are going to provide the secrets for. Click Next. And then you need to provide a secret name. You can use the strategy of using slashes to have different names for different environments and different versions of your application. Okay, so I'm just going to select dev MySQL creds. Okay, and then you can have a description as well in there for what that particular secret is used for. Leave everything else again as it is and click Next. This is the page where you configure automatic rotation. Now, we're going to skip this for now, okay, because I just want to revisit this a little bit later. Click Next, and then once you're happy with all of this, click Store. Okay, so this now configures your secret. So if I just quickly refresh this page, there's my secret Currently rotation is disabled. Like I said, we will revisit that, but all of my secret information, so my credential information for my database, is actually stored in secret. So if I click retrieve secret value, okay, you'll actually see all of the data related to my database come out, including the username and password that I specified. Okay, so that's Secrets Manager created for us. Next, we're going to move on to step 4. Now, step 4 is we need to set up some permissions and an IAM role in order to allow EC2 to access Secrets Manager, as well as obviously interact with the Elastic Beanstalk service. Okay, so let's do that next. Okay, so for step 4, we're going to create an IAM role with necessary permissions. Now, the purpose of creating an IAM role is to create an instance profile. An instance profile is something that you attach to an EC2 instance when it needs to have certain permissions assigned to it so that it can go and do something. It can interact with other services on the AWS platform. An instance profile is essentially a container for the IAM role that has the required permissions. So this instance profile that we're going to create will need to have an IAM role that we need to define that allows our EC2 instances to interact with the Elastic Beanstalk environment. Now, the role is going to grant the EC2 instances to perform specific actions. So for example, retrieving application versions from your S3 bucket, writing logs to the S3 service. If you're using ECS and Docker environments, as we previously discussed, then obviously coordinating the deployment of ECS container services. And if you are building a worker environment, then performing actions like being able to read from the SQS queue, for example, is another permission that the EC2 instances require. So we're going to move on and create our IAM role in this step. Let's get back into the AWS Management Console. Okay, so back to my AWS Management Console, we're going to go ahead and go into the IAM dashboard. So I'm just going to open IAM in another tab. And in IAM, we're going to create this IAM role that's going to be consumed by an instance profile that will be attached to your EC2 instances that Elastic Beanstalk deploys. The EC2 instances with this instance profile will have the permissions to interact with Elastic Beanstalk. And we also need to grant the EC2 instances permissions to interact with Secrets Manager. Remember, Secrets Manager has a secret that we configured that has the credentials of our database. In order for your EC2 instances to talk to Secrets Manager and pull that secret, okay, it needs permissions to do so. So let's do that next. From the left-hand side, go ahead and click Roles, and then click Create a Role. And it's an AWS Service Role entity type, and the trusted entity is going to be EC2. In this permissions policy, filter AWS Elastic. And what that will do is that will give you a series of managed policies that AWS has created already for you that you can use. Now, the 3 policies that you need to use are AWS Elastic Beanstalk Web Tier, AWS Elastic Beanstalk Worker Tier, and AWS Elastic Beanstalk Multi-Container Docker. Okay, we're just adding some additional policies, but essentially these permissions allow you to do things like upload log files to S3, interact with SQS if we did create a worker tier, and all that stuff. So I'm just creating a role that has all the necessary policies. Scroll all the way down, click Next. Let's give the role a name. So I'm going to call this one Dev EB EC2 IAM role. Okay, so I know exactly what it is. And then we'll click Create a Role. So at the moment, what we've done is we've created the role with those 3 policies, but we still need to, if we go to dev eb ec2 IAM role, add an inline policy so that the role can also talk to Secrets Manager. So click Add Permissions, click Create an Inline Policy, click on the JSON tab, and I've actually got a policy that I have created for you, and here's the policy. It's available to you in our GitHub repository as a sample policy, and you're welcome to use this policy along with the application code when you deploy the application in your AWS account. So just to show you what the policy does, the effect is allow, so it's an allow policy, and the action is the ability to get secret value from Secrets Manager. And in order for the policy to work, you need to provide the Secret Manager ARN, the ARN of the secret that you created. So let's grab that policy first, and we'll replace this with our policy, and then go back to Secrets Manager and just grab the ARN of the secret you created, which is that one over there in my case, and replace the placeholder value with the actual ARN. Okay, and then click next. You need to give the policy a name. So this is dev eb ec2 secrets policy. So I know exactly what it is, and click create policy. Right, there's our IAM role. It's got the 3 Elastic Beanstalk managed policies that AWS manages, and it's got 1 inline policy that I have put in there that I manage that has access to Secrets Manager of that specific secret ARN. Fantastic. Let's move on to step 5. Right, you've done all of the prerequisites. You've built the VPC, you've deployed an RDS database in that VPC, you've configured Secrets Manager, and you've set up the necessary IAM roles with all the permissions that you possibly need. Next, we're going to move on and actually work with Elastic Beanstalk and deploy the application into Elastic Beanstalk. Before you do that though, you need to download the application source code bundle from our GitHub repository. So let me show you where that is first, and then we'll jump back into the AWS Management Console and deploy this application. Okay, so you have access to the application source code bundle that we're using for this project. It's available in our GitHub repository, the link of which is available to you in the resources section of this video or down in the description box below. You'll need to download the EBS RDS to-do app code version 2's zip file and place it on your desktop or in a location that's easily accessible. You will actually be uploading the zip code bundle as it is, as a zip file, to the Elastic Beanstalk application when you configure Elastic Beanstalk, but I wanted to extract the contents of the zip file and just show you what it contains. So let me do that first. Okay, so here we are, the contents of my application source code bundle. It's got a few files and a few folders. And specifically, it's also got the vendors folder, which has a lot of the SDKs that AWS supplies for its various services. So the application makes use of those in order to connect to the Amazon Web Services platform and make use of certain services. Now, specifically, there is an index.php file and a server.php file. All of the front end look and feel is all set up in the index.php file. The server.php file is what connects to the backend database and performs all of the backend magic. Let me open that up for you in Visual Studio Code. Okay, and there we are. So this is my Visual Studio Code with the server.php file in its open state. And I just wanted to quickly show you a couple of things over here. Firstly, this includes the AWS PHP SDK, so it allows you to interact with the platform as this application is built using PHP. What it does is it imports the Secret Manager client and the AWS exception clients as part of the code. And then it also specifies the region that it's working in. Okay, and furthermore, it actually is able to retrieve the secret value from Secret Manager, okay, and it stores that as an environmental variable. Now, the important thing is that the secrets, particularly the username and password, are encoded in plain JSON string, and there's a JSON decode function here that basically retrieves that username and password. And once it retrieves that username and password dynamically, it is allocated to 2 variables, which are DB username and DB password. DB server and DB database are additional names that we will add in the Elastic Beanstalk environment properties from which it will retrieve those values. But the username and password will be dynamically retrieved from the Secrets Manager client. Okay, so that's why this becomes very, very secure as it's dynamically retrieving the credential information, and subsequently we will be able to also rotate those secrets and continue to still access the database because we will dynamically retrieve the credential data. The EC2 instances on which this particular piece of application code runs on has the instance profile and therefore the IAM role to be granted access to Secrets Manager. And that's where the power of IAM roles and IAM profiles come into play. Okay, enough about all the code and stuff. Let's actually jump back into the AWS Management Console and set up our Elastic Beanstalk application. Okay, so back into my AWS Management Console, we're going to go into the Elastic Beanstalk dashboard. So in the search bar, just search for Elastic Beanstalk and open that up in another tab. So the first thing that we're going to do is create the Elastic Beanstalk application. Remember that the application is simply the container that will host your environments within which we will deploy the application. And I'm going to give the application a name. So this is a dev to-do application. So the application that you'll be deploying is actually a to-do list application that allows you to create your to-do list, and it saves that data in a backend RDS database and performs all the CRUD operations against the database. So let's take a look at what that application looks like. So we'll go ahead and create the application. And once you've created the application, we then need to create an environment within which to deploy the actual application code into. So when you click configure environment, you need to select whether you're setting up a web server environment or a work environment. So we'll be creating a web server environment, which incidentally has both the front end and back end elements in it. In a real world scenario, depending on how complex your application is, you want to probably split the two, as we've discussed in our previous slides. But for now, let's just create the web server environment. So the web server environment has been built for our dev to-do application. And you could choose your own domain name. I'm going to leave that as default as well. You'll just need to type in a preferred name and then check that it's available. When it comes to the platform, ensure that you select PHP because the application is built using PHP. The platform branch is going to run on a 64-bit Amazon Linux 2, and the version is 3.5.9. Next, you want to upload the code. So this is going to be the zip file bundle. So you want to click local file and select the location where you have your application source code bundle downloaded. So in my case, it's over here. So remember, you want to upload the zip file itself, okay, and click open. Next, you want to click on high availability because we want Elastic Beanstalk to provision load balancers and auto scaling for us for high availability, and then to scale out as well as scale in. Click next. Oh, need to give it a version name. I'm going to call this one V1 and then click next. Okay, so the next step is to create service access. Now this is where creating necessary IAM role comes into play. Now what you need to be aware of are there are two roles basically used by Elastic Beanstalk. There's a service role that allows Elastic Beanstalk to assume the service role and to perform various Elastic Beanstalk actions against the environment that is being built. Now you could get a service role created for you. I've got one previously created, so I'm just selecting the same one. Just to show you what permissions this service role contain, let's go back into IAM roles, and this one over here, AWS Elastic Beanstalk service role. Essentially, it contains two managed policies that allows for health monitoring and managing updates on the Elastic Beanstalk environment. Okay, so that needs to be selected, or you create one from scratch. So you allow Elastic Beanstalk to create it for you. Next, you have the EC2 key pair. Now, this is only needed if you're logging onto your EC2 instances. However, I strongly recommend that, instead of using EC2 key pair to use SSH to log onto your instances, you use AWS Session Manager. If you want to know a bit more about Session Manager, check out our other video in this course that talks a little bit more about how it works. And then finally, you want to select the instance profile. Now, this is the IAM role we created a few moments ago that has necessary permissions to allow our instances to talk to Elastic Beanstalk, S3, SQSQ, depending on which environment you're placing it in, as well as the inline policy to allow the EC2 instances to retrieve the credentials from Secrets Manager. Okay, so you select the instance profile there and click next. Okay, now in the networking database and tags option, for the VPC, select the VPC where we're going to deploy our Elastic Beanstalk instances in, and that's the dev VPC that we built right at the start of this lab. And then you need to specify where those instances need to be deployed. Now remember, in our architecture diagram, we created the app subnets, okay, which was a private subnet that we want to use for all of our instance deployment. So that was app subnet 02 and app subnet 01. Okay, so these two subnets are going to be used to deploy our instances. This option allows you to configure a database integrated with your environment. And we said that whilst this allowed you to quickly and easily set up databases in real world production environments, you probably want to have your database externally hosted from the environment. So we're not going to enable database here. In any case, we already have our RDS database already configured. Scroll all the way down and click next. Okay, now with regards to configuring the instance traffic and scaling, okay, leave the root volume at its default settings. For the EC2 security group, make sure you select the dev app server SG security group. Remember, the purpose of creating this security group was so that we can define a source for our database security group. Okay, so our database that we launched in the RDS section of this lab has this particular security group attached to it, the dev database SG, and it allows inbound traffic on port 3306, the MySQL port, only from instances associated with the app server SG. So we want to make sure that when Elastic Beanstalk launches your instances, it attaches the security group to it. Okay, so all of our instances must be attached to this security group. From a capacity point of view, it's going to be load balance, and I'm just going to put 2 over there. Okay, scroll down a little bit further, and we want to just go with the T3 micro type. So I'm just going to remove T3 small. We don't want it to be charged. We're going to use free tier. That's the AMI ID that Elastic Beanstalk is going to use. We're going to leave all of these other values as it is and move on to load balancer network settings. Now for the load balancer, you want to place a load balancer in the public subnet. Okay, the nodes need to be deployed in the public subnets, and specifically that's going to be public subnet 01 and public subnet 02. Okay, because the load balancer sits right at the edge, receiving traffic from the internet and relaying that traffic back into instances in the private subnet. And the type of load balancer is going to be an application load balancer because we're routing HTTP traffic in this case. And then you want to pretty much leave everything else on this page at its default value and click next. Okay, when it comes to configuring updates, monitoring, and logging, for the help reporting, ensure that it's set to enhanced. You could set up email notifications if you wanted to be notified of important events in your environment. And then there's also the rolling updates and deployments for when you make upgrades to your application. Now we have another video that talks about this in a bit more detail as an advanced topic. Feel free to check that out as well. But for now, just leave everything at its default value. Scroll down until you get to environment properties. Now this is the important part. For the environment properties, you're going to set up 3 environmental variables. So the first one is going to be the DB underscore endpoint. Okay, so this is the actual DB server endpoint. And if you go back to your RDS management console and go into your database and click on your database, that's this one over here. So you've got the endpoint value there. You just want to grab that and place that in there. Next, you're going to add the DB name. So DB underscore name, and this is going to be dev DB. Okay, and then finally you want to type in the secret name. Okay, now the secret name is the name of the secret that hosts my credentials. So if I go back to secrets manager, that's this one over here. So that's my secret name, and we're going to place that value in there. And our EC2 instances are going to connect to secrets manager, look for this name, and pull the username and password for the database dynamically. Okay, then we click next. This is your page to review all of your settings, make sure it's all in order, and finally click submit. And so now what we're doing is we're submitting the job to Elastic Beanstalk to go and do all of its magic. And in the backend, it's going to use CloudFormation to build everything for us as per our configuration requirements. Okay, so it says Elastic Beanstalk is launching an environment. This will take a few minutes, and it does take a few minutes. So why don't you go ahead and grab yourself another cup of tea or coffee? I'll pause the video for now, and once this is all set up, we'll continue from where we left off. Right, welcome back. Now, our environment has successfully launched. So Elastic Beanstalk went ahead and did all this wonderful magic in the backend to set up our environment and to deploy our application onto the AWS platform. Now, Elastic Beanstalk gives you a domain name to connect to. So if I open this up in another browser tab, you will see that the application has now come up. So this is a to-do list application. Okay, it gives you the date and the time, and it gives you this little form that you can fill up. So let's give it a try. So let's say I have a work to-do list. Okay, complete video on Elastic Beanstalk. Okay, and the due date is, it has a nice calendar format. Let's put in that date, and the status is in progress. So I'm going to click submit, and it says to do, added successfully. Well, nice to know. And if I scroll a little bit further down, you will see that my table is updated. Okay, fantastic. Let's add another one, another work one. Okay. prepare Elastic Beanstalk deployment presentation. This is going to be the next topic that I'm going to work on. And the due date is, let me give myself some time to work on this. And it's not started. Let's submit that one. And there you go. So you can see what's happening. This application interfaces with the backend database, the RDS database. It stores all of this data in the RDS database, okay? And it also retrieves the data from the RDS database. So it's a PHP application. It does this bit of magic and performs all the CRUD operations for the database. I can change the status. So let's say I've already started working on something over here, maybe started, and that will change the status, and that's all done. So once I've completed this video, I'll click completed and it will change the status, and it gives me a nice green block as well. So my intention is to get everything green for you guys so that I can prepare more videos like this one. Well, I hope you enjoyed the application. As I said, it's just a simple application, just a one-pager. But it demonstrates the fact that this is a multi-tier application. There's a front and back end element to it. There's a database element to it. And you can use Elastic Beanstalk to provision the underlying infrastructure, deploy the application, and manage its lifecycle. I wanted to also give you a quick run through about some of the things that Elastic Beanstalk has done. So if I go into the VPC section, you'll see under security groups, Elastic Beanstalk went ahead and created 2 more security groups. This one over here, for example, is the load balancer security group, so that it is configured the inbound rules to allow traffic on port 80 from the internet. And this next one is a VPC security group that in fact has the source as the load balancer security group. So now if I go into EC2 in another tab very quickly, okay, let's go into EC2. You'll see that one instance is running. That's my instance that was deployed by Elastic Beanstalk. Okay, there it is. And that particular instance, if I click on security, is attached to 2 security groups. One is the dev app server security group, which we created, and one is the one that Elastic Beanstalk created. So in effect, this instance has 2 security groups, one to accept traffic from the internet via the load balancer, and one to act as a source for traffic that's going to hit the database in the backend. Okay, so that's how the security groups work in this architecture. So Elastic Beanstalk has also provisioned our load balancer. So if I go on the left hand side and click on load balancers, okay, and you can see this is a load balancer that Elastic Beanstalk deployed for me, and Elastic Beanstalk manages this load balancer. Go down to auto scaling groups, and you can see that Elastic Beanstalk has also provisioned the auto scaling group, and its activities are available to me as well. Okay, so Elastic Beanstalk did all of this heavy lifting that I would have had to do manually if I wasn't using Elastic Beanstalk. Okay, so now that all of that is in place, just go back to the application. Our application is fully functional. It's performing all its CRUD operations and it's connecting to the database. There's one more step left. Let's go on to step 6. Now for step 6, I wanted to go back and revisit Secrets Manager. I wanted to update the secret that we had created earlier in Secrets Manager to enable rotation of the database credentials. And as long as your application code has been designed in such a way so that it can use the SDKs and interact with the AWS services, it can dynamically retrieve updated credentials from Secrets Manager and access the database and the backend. So let's get back into the AWS Management Console and edit the secret that we created earlier. Okay, so here we are back into our AWS Management Console. Let's just go into our Secrets Manager and go into our secret. And all I want to do is go down to Edit Rotation and enable automatic rotation. And I'm going to make a change to the rotation schedule and set that to days and set it to every 7 days. Okay, and we're going to go ahead and basically enable Secrets Manager to create a rotation function. Okay, and we can add a particular value here, so it will have the prefix of Secrets Manager, and I'll do something like MySQL dev cred rotation. Okay, and then we'll click save. Now what this is doing is actually enabling the feature for rotating my database credential. Now you may have noticed that very briefly the rotation status went to enabled and then it's gone back to disabled, and that is because CloudFormation in the backend is performing all the magic. It's actually setting up a stack in order to enable this feature. And if we quickly went into CloudFormation, and if I open that up in a different tab, you will see that Secrets Manager RDS MySQL rotation is in a create in progress state. So we're just going to have to wait for this to run through. And then once it's complete, we should find that rotation configuration has been enabled. I'm going to pause the video over here, and then we'll come back as soon as the CloudFormation templates have been deployed and the stack is ready. Okay, so here we are back at my CloudFormation console, and you can see that the stacks have been deployed. The status is set to create complete. Okay, so we're good now. What this basically means is that if I take you back into Secrets Manager, you will see that the rotation status is set to enabled. It's going to happen every 7 days, and that's the next rotation date. Now, what actually happens in the background is that CloudFormation creates a Lambda function, and the Lambda function integrates with our database and is able to change the credentials, in this case every 7 days on our database. Now let's just take a quick look at the Lambda function itself. I just want to show you what's happening. So if we go into Lambda and take a look at our Lambda function. So this is the function that CloudFormation created. Okay, it rotates the Secrets Manager secret with the MySQL credentials at the specified schedule that we defined when we enabled rotation. Okay, and it gives you the function ARN. If you scroll down a little bit and go into configuration and VPC, there's something I want to point out over here. Your Lambda function needs permissions to talk to the database, and when AWS CloudFormation creates this Lambda function, it associates it with the same security group that the database is associated with. In this case, dev database SG. So CloudFormation configured all of this up for us. So our Lambda function is now associated with the security group dev database SG as a means of now being able to communicate with our database. However, there's a slight problem here. If we go to this security group, so if I go back into VPC, okay, here's my VPC, these are my security groups. If I go into dev database SG and go into inbound rules, the only entities that can communicate with our database, okay, is in fact any instance associated, or any resource for that matter, associated with a dev app server SG. Okay, and this is important. Although your Lambda function is associated with the dev database SG, which is the same security group that the database is associated with, you will see that the dev database SG is the security group associated with the database. The problem is that the only resources that can communicate or send traffic to the database on port 3306 are any resources associated with the dev app SG. And so what this means, and hopefully you've got this already, that the Lambda function will perform the necessary action that it needs to perform, but it will fail. Okay, it will not be able to change the database because technically it's not able to send traffic to the dev database SG. So what we're going to do is we're actually going to create a new security group and attach it to the Lambda function and use that to grant the Lambda function the ability to access the RDS database. So create a new security group. Let's call this one dev lambda SG. Okay, and I'm just going to give it the same for the description. Make sure you put it in the right VPC and click create security group. Okay, now, so that's the security group created. We then need to go back to our security group lists, go to the dev database SG, edit inbound rules there, and add the same MySQL traffic from the Lambda SG. Okay, so that's this one over here. Okay, so we're allowing inbound traffic from any resource that is attached to the Lambda security group on port 3306. So we'll save that. Okay, and also just whilst we're here, let's just copy this name and put it under the name column just so that we can easily recognize all of our security groups. So that's good. And then go back into your Lambda function. Okay, and in your Lambda function, you want to go back to configuration, back to VPC, and then edit the security group configuration. So currently the security group is set to dev database. We want to get rid of that, and you want to select the Lambda SG security group, and then click Save. And at this point in time, the Lambda function is going to be updated so that it can consume and use the dev Lambda security group in order to make its connection to the database that we have in the backend. Now, this takes a few moments to complete, so I'm going to pause the video over here again and then come back as soon as it's done. Okay, so as you can see, the configuration has now successfully updated the Lambda function. And so the Lambda function is now using the dev Lambda SG group in order to grant it the necessary ability to talk to the backend database. So if we go back to our secrets manager, what we should be able to do is click rotate secret immediately and not wait for the 7 days. And I'm just going to click rotate. And then if we go and click on retrieve secret value, you will see in fact that the secret has now changed. So this is not the password I had used when I set up the database. What this means is that Secret Manager has made use of the Lambda function. The Lambda function has updated the database password. And now our application should be able to pull this new password using the environment properties that was configured in Elastic Beanstalk to say where to retrieve the secret from, i.e. from this secret name here. Okay, so now if I go back to my application and just do a quick refresh. Okay, so that's refreshed my page. Okay, so if we scroll down, we can see that we can still read from the database. Let's see if we can add stuff to the database. I'm going to click on another work task and I'm going to say create slides for machine learning. Okay, and the due date for that is, I'm going to set a due date to 30th of July, and I'm going to say not started, and click submit. And it says to do added successfully. And if we scroll all the way down, and yes, indeed it has. So in fact, the new credentials are being used. The application has dynamically pulled those credentials and it's still able to communicate with our database. Fantastic. Our multi-tier application has been successfully deployed. It is using best practice methodologies about where the application is based, the database placement within the VPC. It's also using Secrets Manager to interact with the database, and it's in a highly secure VPC configured with necessary security groups and permissions. It also uses IAM roles that grants it the necessary permissions to interact with the other services on AWS. And so hopefully this has been a really useful hands-on demonstration of how to deploy an application on the Elastic Beanstalk service. The application source code, as I mentioned to you earlier, is available to you absolutely free of cost. And so you're welcome to try this out in your own environment. Follow the step-by-step guide in this video and gain that much needed hands-on experience of actually working with Elastic Beanstalk, because that's how you will develop your skills on the AWS platform. Now, if you enjoyed this video and you found it useful, please hit the thumbs up and please subscribe to this channel so that I can notify you as and when I release new AWS projects and you can continue to develop your skills on the AWS platform. Thank you.